Welcome. I appreciate everybody who found his way to this last session before the party. Let me just right away start introducing myself. My name is Stefan Hermann, and while introducing, I recognize I kind of have a split identity. So the logo to the lower left indicates that I'm working via my daytime job for a company called GK Software. We're doing retail software, and my interest in that company is providing the tools so that developers are more productive in their work. The next people who know me would probably expect me to speak at a Java 1 about my work on Eclipse, and specifically I'm a committer on the Eclipse JDT, where I contributed null analysis based on annotations and all this stuff, which is not the topic of today, because I'm very happy to speak today about the project that's most dear to my heart, which is also an Eclipse project, but originated from a university project actually about 10 years ago, which is a project called Object Teams. And I will be speaking about modularity, hopefully in a way that's quite different from what you heard on modularity during previous talks in this conference. So I hope to set some ideas that will make you think differently about modularity. I will not speak about modularity as a goal in itself. So my focus is modularity for the purpose of building reusable software and for reusing those modules with different variants and all that, and how we do this with Object Teams. And the very brief introduction to Object Teams is that we have a language called OTJ. And yeah, this diagram pretty much says it all. OTJ is a specialization of Java, which means most of the syntax is just Java syntax. So I will not show a whole lot of source code, because most of the source code in Object Teams is actually looks exactly like Java. So I will focus on the concepts behind that and try to explain how we approach modularity. And to start the story of modularity, let me start right at the beginning with a little history of spaghetti, because that's what we're trying to solve here, isn't it? And in the beginning, the word consisted of different instructions or statements. Some of them are listed here, and then people found that one of these instructions is dangerous. And so with go to considered harmful, they found that the real danger is here. Jumps are dangerous because if you use them in an undisciplined way, that every statement in your program can potentially branch to any other location inside the same program. So you have the any-to-any relationship between locations in your program, and this is kind of the definition of spaghetti. Everything is tangled with everything else. And as we all know, this is not modular. So this is the start of spaghetti in software. And luckily, people found a solution, maybe something like in the 1960s, where they found that those instructions should be grouped into, as we all know, subroutines or procedures. Now we call them methods. So problem is solved. Spaghetti is solved. We can go home, have a beer, and all is fine. Except they forgot one essential thing. They solved the problem for control flow. They did not solve the problem for data. Because if you only have procedures as your only kind of module in a program, how do you share data between the different procedures? And the first primary approach might be to pass data as parameters to those procedures, but you cannot pass all the data through parameters into all the procedures. So the most convenient thing is to just have global variables and share state via global variables. And what happens? Now each procedure can relate to every global variable in the system. That means, what do we have? We have data spaghetti. Great, so we are upgraded from instruction spaghetti to data spaghetti. And as we all know, spaghetti is not modular, that's not what we want. So, luckily, here came object orientation. Now we are able to combine procedures and variables into classes. And with that, yeah, the problem is solved. The data is included in the modules and no longer everybody relates to everybody else, and this is fine. Unless your system grows and grows, and as you have thousands of classes, and with the potential that every class relates to every other class, what do we have? Class spaghetti. Great. So if you like spaghetti, enjoy your meal. I'm into software. I want to get rid of this. And if we observe the timeline, we want to create everything as a module. And we start with statements, which are tiny. And then we group, let's say, about 20 statements per procedure is a pretty good metrics. And then we group 20 of those procedures into a class, etc. What happens actually in Java land? We're adding packages at the next level, so we may be able to cope with 8,000 lines of code. Great, but packages are too fine-grained. So what do we add? OSGA adds bundles, or what you name it, and on and on. The number of names for modules greater than classes wouldn't even fit on the slide, I'm afraid. So if you're a researcher, this is very good news, because you will remain in business, you will remain busy inventing new kinds of modules as we go, and as software grows and as the software gets more complex and larger and pervasive. From an economical point of view, this is completely insane if we have to invent new kinds of modules over and over and over again. And since I'm a great believer in object-oriented programming, I think classes and objects are wonderful means of structuring your software. Wouldn't it be great if we have a system that consists of a few classes, and if it gets larger, wouldn't it be great if we could just use this, wrap a box around it, call this a class again, then we have another class with nested classes, have another class with nested classes, and all we do at this level, connecting these three classes, and if the system grows larger, zoom out, this is the old system, create a box around, this is a class, and here's another class, and we only have to connect them at any level of scale. We only deal with classes, and we're done. Modularity is solvable at any scale with only using one kind of concept, classes. Could be enough. And sounds pretty cool, actually, except here's one consequence of using this approach with Java and classes and inner classes. Why is this not feasible? It simply doesn't work this way, because it would imply that your entire application would have to be coded in one file. Now, that's a very big, great reason not to use this kind of technology, is it? So, now we learn why Java actually has the next level of modules, which is called packages. Because packages are good in structuring files and folders. And they even have a hierarchical ordering, structuring of folders, although the packages themselves are not in a hierarchy. By contrast, classes are conceptually very powerful means of structuring your software. They have this boundary between here's a signature, here's the implementation, and classes even support nesting. And I should repeat, packages, although it looks like, do not support nesting. Right. So if I want to create a module in Java, I have to choose. Do I want to create a class, or do I want to create a package? And the warm-up into object teams is to show just a very, very small addition to the Java language, where we say this option to choose either a package or a class is a bad choice. I don't want to be asked this question. I want to have a class that can be structured into files in subdirectories, corresponding to the nesting of the class. So, as the name object teams kind of implies, we have a new kind of class with a modifier called team. And this kind of classes has properties of both modules, classes and packages. And if you look at a class structure in the Eclipse Package Explorer, you have two options. Either you're interested in the logical structure, and then you'll see that there is, for example, a team class, the yellow thing, which has directly nested classes, for example, a citizen, there could be a mayor, there could be a town hall, there could be all different kinds of member classes of the team. Direct members. This is a logical view. It doesn't show any files, actually. It shows a top-level file. But if instead you're interested in the file structure and how do I store these in a version control system, for example, all these things, then I only have to toggle the button on top of this view, and then I see the physical view. And the same project actually looks like this, where we have the same classes, a city and a citizen. And the meaning is the same, but we have two additional nodes. We see that the team community.city actually corresponds also to a package community.city. And inside that you have a file for the nested class. Very, very simple trick. And you just choose, I'm interested in the logical structure or in the physical structure, and then by a toggle of the button you see this or that. And so that's actually the first item for you to take home from this session, that with team classes, you are no longer forced to choose either a package or a class. You can use something that's both. And by unifying classes and packages, we finally made nesting really feasible. It works. And you can even do an incremental compilation of inner classes. And so there's no longer excuse for not using nesting as a means to scale your modules, and just use the core object-oriented concepts, classes and objects. So life would be nice if this would be all we need for modular software. And this is a very, very much simplified view of the world, of course. If we could have these Lego bricks and just group a few of them into a larger module, and then have some of these prefabricated modules, and then just hook them on top of each other. If software composition would work just like that, and the top level block would then automatically be our system, it would be great. But life is different. Life is more complex, and there's different ways of looking at the complexity that forbids creating softwares using only this hierarchical breakdown. And one aspect of this complexity that I'm especially interested in is reuse. Because now we're not only speaking about breaking down one single application into this neat hierarchy, which is very difficult to find, but now we're speaking about one module being part of many of these hierarchies. And so there's conflicting interests how the modules should be structured in each different application, in each reuse scenario. There's different demands on the same module. So that is the challenge I want to address in the next step of this presentation. I would say the core problem, the core difficulty in reuse is that here's a requirement from a customer. Here's a module that looks pretty much like what I need. But there's this 2% mismatch or 5% mismatch. And so I'm typically forced to either say, well, the customer doesn't get exactly what he wants, or I'm forced to just not reuse that thing or anything of that kind. And the true art of reuse is to transform this near miss, that's almost what I need, but not exactly, to transform this into a perfect match. Because I want to deliver exactly what the customer requires, not something only similar. And this could be called a problem or a difficulty in reuse. I would actually say this is the essence of doing reuse, to be able to transform a near miss into a perfect match. So what do we need? We need a tool that allows us, here is an existing module, we want to use it in our application with a few adaptations. And I'm not speaking just about those adaptations that the module provider already anticipated. That's easy. So if a module provider just adds a bunch of parameters to the module and we just configure the module and then it does what we do. That's easy and it wouldn't be worth a presentation at Java 1. The problem that I want to tackle here is the problem of unanticipated adaptation. That is, I'm going to do something with this module that the provider of that module did not think of. And this is the part that creates new value, I believe. And in object-oriented programming, which I'm a fan of, this is actually more or less the tool we need to solve this problem. Because with inheritance, we have both these properties. We acquire everything that has already been coded. So we inherit all the methods from the superclass. And for those methods that don't fit our needs, we're allowed to override them. We're allowed to adapt those bits and pieces that don't fit. Unless people were very, very keen on final and private and static on these things. Let's leave this discussion out here. Basically, inheritance is a very good tool for doing this. And the observation, if we map this onto what I said a minute ago, is that for methods, this works pretty good. But if we are starting with a system that's constructed from classes with inner classes, with inner classes, there's no way I can change the implementation of these inner classes. Inheritance of classes, of inner classes, is broken in Java. It doesn't work the way I want it to be. So if inheritance is defined by acquire everything and adapt the things you need, it doesn't work for inner classes. Oh, that's pretty sad. And let me show you what I would like to be able to do with classes with inner classes. So I want to be able to create a module that implements the common parts of all board games on the world. So there's players, there's tokens, there's moves, there's rules. These are common parts of more or less all board games that we have. And if I want to implement a specific board game, I want to be able to just create a new module just by inheritance from this one existing big module. And this includes that I want to be able to refine also the inner elements. So the player, the token, the move, the rules now should be chess player, chess token, etc. And with object teams, we have the capability that with team inheritance, team classes inheriting from another team class, this overriding of inherited inner classes is possible. This is a concept that is a very established and well-known concept actually in computer science. It's called virtual classes, like virtual functions are functions that are overridable. Now, virtual classes are classes that are overridable. So don't worry, this is not something fancy I just made up on a crazy night. This has established theory behind it. And what I can do with this, it allows me to consistently refine all the elements, all the inner classes that I inherit from the super. And with consistently, I mean, it is not possible. The type system prohibits. It's not possible to mix, for example, a chess player with a tic-tac-toe token playing by the rules of a checkers move. This is simply not possible, and there's quite some type theory behind this, and which takes care of this. The good news is, even if this is quite sophisticated stuff, in the normal case you don't even have to see the difference between a regular Java type rule and what's going on here. So it establishes consistency, which is pretty great. And for another property of this team inheritance, let me expand the example just a little bit. Assume we already have the chess game fully implemented, and now we want to make just a little derivation. And this is something like a near miss and transform it into perfect match. I want to have a blitz chess, which means it's exactly the same rules as chess, just you have to complete each move within 10 seconds. So all I need is to override, let's say, the method rule.validate, and this method takes care if more than 10 seconds have passed, the move is no longer valid and you lost. So it's a very, very tiny adaptation, and with virtual classes, what I need to do is I can do deep overriding. That is, I inherit a class rule, I override this rule, and inside that overridden class, I can override its method validate. So I can selectively drill into the inherited implementation at any level of nesting and can override specifically that method that I need to override. Which means, forget everything you learned about frameworks. If there is a module that implements some functionality, in order to adapt this to your application, all you need is this kind of nested inheritance with overriding and deep overriding, in fact. And it's not only very, very flexible, it's also modular again, because the overriding, the inheritance actually happens at the level of the outer. And it is, again, not possible to mix specializations that don't fit together. And in fact, it's only one statement, the instantiation of the outer, that decides about all the behaviors of the inners. So as soon as I say, I want to create a new blitz chess, this decides that all the rules we'll be talking about from here on in this context will be blitz chess rules, which means all the implementations of validate will always be the implementations from this specific overridden class. So this is for the consistency. Just one instantiation decides all the other individual selections. So this is item number 2 for you to take home, and it's already very, very powerful means to combine modularity with reuse and truly unanticipated reuse. Would be worth a JSR, but I'm afraid this is too big a change for Java to ever do in the next 10 years. But this is just step number 2 on what we're doing in object teams.
Question, or do you want
sure.
to So I'm curious, right? So typically in ordinary Java classes, you can only override public and protected and default if you just take package methods. And sometimes, when you come to a situation where you want to change it was not anticipated, and really what you need is you need access to a private method.
So I have to ask you to hold on to this question, because this part of the story of object teams plays by the rules of Java visibility.
Okay.
But that's not the final answer. There will be more to it. So we've been speaking about taking classes very, very seriously, taking inheritance very, very seriously, and using those for modularity and for reuse. So another way of describing what we did so far is that we describe the commonalities of what we want to reuse by superclasses, which may be abstract or not, and describe the variations by subclasses. And with object teams, we added the capability to do this with even larger things, so we can have abstract team classes as the common parts and sub-teams as the variations that we create. This is great so far, but it's only a part of the story of reuse, because so far we are only speaking about how do we decompose a system into variations and reusable parts. We haven't spoken about reuse that much. And in order to get the full picture, we also have to think about how do we compose those variations into a running system. And that may be even harder than the first 2 steps we saw. So, okay, here it says creating a system. LibreOffice didn't like this line, so it keeps deleting that. So in order to compose a system, we have to ask ourselves a question like this: how do I select among the different variants that are created on the top part of the slide? How do I select them, and when exactly do I select them? Which is actually two questions. When in the development process can I select a variant? Or maybe I want to do some of these selections even later at runtime. Will I be able to do that? And to make the challenge even more fun, I don't like to speak about just one-step reuse. Because, as you may remember for the first part of this talk, I don't like solutions that only get you one step further. I like to have a solution where everything you create is reusable, and somebody else can create something new from it, and what he will create is again reusable. And so we have arbitrary changes of reuse. This is what I consider fun, and so let's see how we can do about this. Now, we're getting at the very core of object-oriented programming, actually. So, for the flexibility we need for reuse, we're using polymorphism, right? So, each variable that you have has a type, and that type is only describes a range of possible behaviors. And the actual selection is postponed. And thus, the module is reusable. Cool. If we peek down into what happens at runtime, at some point, we will have an instance with a specific type, and that type decides exactly what behavior this application will have at this point, and this instance is locked to this specific behavior. So, what happens between here and there? On the top, we have the flexibility, and this is reusable. On the bottom, we have something that is locked to one particular behavior, and it's no longer adaptable. What happens between here and there? That's a very innocent, little, tiny keyword in Java that makes this transition. It's the word new. Whenever you use this keyword, you're making a selection. And so instantiation has a great responsibility in this game, because with the instantiation, we actually select the behavior if we use inheritance as our mechanism for creating variants. So we select the class, by that we select the variant among the different behaviors. And the bad news is that the new statement hard codes this decision into your programs. And this selection is final. So you have to choose. Either you create your application as reusable, and then you're not allowed to use new. Or you have to use it at some point, and at that point your application is no longer fully reusable in the sense. You may have some mechanism to allow some reuse, but it's not completely reusable for any unanticipated adaptation, for all unanticipated adaptations. So new is a very, very powerful instruction, and it has very great responsibility in this game. But the reuse by this mechanism is limited to one step. As soon as you say new, this decision has been made and it's fixed. The selection cannot be revised. And so in this kind of conflict, there can only be one winner. The one who decides what type to instantiate. And now people start saying, well, maybe we should just say new is considered harmful, don't use it. And then they have patterns and say, well, you shouldn't use new, you should use factories in the beginning anyway, or maybe you should use dependency injection. Entailing a long discussion we could have here, but I'd like to make a shortcut here and say all these approaches, they may take you a few yards, but they are not the full solution. The full solution has to acknowledge that the core problem we're facing, and why we have this contention with the new instruction, the core problem is an inherent limitation of inheritance. Now, this is kind of bad news, because I started saying classes are great, inheritance is great, object-oriented programming is great, this should be all we need. And now I'm saying inheritance is limited. Well, then people say, I told you, you shouldn't use inheritance, just use composition. And, well, yeah, maybe we should just use modular too. It's a wonderful language for that style of programming, very well in doing modular programming with methods and data in one place, and that's it. Yeah. Seriously, this is a very good language, but I still wanted to do a step forward and say, I want to be able to use inheritance, and if in some situations inheritance is too rigid, I could do one of two things. I could change inheritance, or I could create a brother, something that's similar to inheritance, which does not have these limitations, but has slightly different properties. And that's, in order to come up with an idea what this brother of inheritance would look like, let's go back to the 101 on object-oriented programming. What is inheritance? What do textbooks say about inheritance? Well, they say inheritance is, if you can say, man is a person, equals to inheritance. A woman is a person, so use inheritance. And textbooks also say an employee is a person, so use inheritance. I mean, at least the textbook from last century used to say this. I've seen it, seriously, in several of these textbooks. But wait. Do I have to choose? Am I a man or an employee? How do I express male or female employees? Doesn't work. Even worse. Who of you has been born as an employee? If I want to have an employee instance, it has to be an employee instance, and there's no way I can derive an employee instance from a person instance. So if you're not born an employee, you will never be an employee. Or even worse, if you lose your job, this object has to be deleted. But that's the person, right? So if you lose your job, the person dies. I hope I have a life after employment. And even more fancy, consider you have two jobs, but you're still only one person, right? So how many salaries do you have? At most one. No good reason to have two jobs then. So what's missing? Inheritance is missing, first of all, the two verbs become and quit. Well, Smalltalk had become. Nobody remembers. So what we need is some dynamism that allows us that an object can change its type during its lifetime. The one direction is very easy, the other direction is easy in certain contexts. To drop a certain slice of an object, and something that is simply not possible with standard object-oriented technology is to have multiple instances of the same field on the same object. Just doesn't work. Yeah, so can we do better? As I said, we could go back to modular 2 programming, or we can try to think of something that has as many of the properties of inheritance as we like, and just change these things where inheritance is too rigid. And the answer is, I didn't even have to invent that. That's been around for quite a while. We only have to rephrase what has been said as employee is a person. That's not a precise statement. The statement we should be saying is employee is a role played by a person in a certain context, at a certain point in time, etc., etc. So just by shifting the phrase, the prototypical phrase we use to represent the model in natural language shifts the focus, and this is how we do this in object teams. Wow, here's a keyword. Language, programming language. We introduce a new keyword called played by. And this keyword sits in the same position where also extends would sit. So it's a similar to inheritance, yeah? And by this played by relationship, we can connect now to separate classes, employee, person, just as we did before with inheritance, nothing fancy. So in order to see the difference, we actually have to move from the class view to the instance view. Here's Joe. Joe is a man. Subtype of person. Okay, so inheritance may, for normal cases, be sufficient here. Joe is a man and he has a name, Joe. When he grows up, he enrolls as a student. So now he is a man and a student. Has some additional properties. So, for example, he also has a matriculation number for his enrollment in university. So what do we have? We have a typing that is dynamic. We can, not to confuse with typeless programming, but the type of this object gets richer by adding roles to it. And we can even add another role to the same object. So now Joe is both a student and an employee. So he has 3 fields: a name, matriculation number, and a salary. And which tells us the same base object can even have multiple roles attached simultaneously. And when he leaves university, he's no longer a student. Joe still lives. And he may accept a second job. Now Joe is 1 person and he is 2 employees. No problem with that. He has 2 salaries. Great, we finally managed to model this. Which tells us the multiplicities exist in 2 dimensions. We can add different behaviors and we can even add the same role multiple times if we have the context information to select. And these concepts have been around in the research on object-oriented programming language about 20 years. And so I actively participated in this discussion in the academic context for about 10 years. So my claim is not I invented role, but my claim is that I pretty much heard everything that researchers said about how should we represent roles in object-oriented programming. And so my contribution basically is to get the best of the breed from all these approaches and integrate all this into one consistent programming language. And that language is object teams. So just a few more details about this role-playing relationship. It's a relationship we first start out by connecting 2 classes. But then we want to be able to call a method getName even on the employee part of the object, although the employee doesn't have that method. That method is defined here, and we do not want to duplicate that method. So we could say all these methods are also visible at the role, but I decided to more decouple both of these parts. So we have to add just a tiny little declaration, which is this getName, right arrow getName, which declares that method calls getName should automatically be forwarded from the left to the right. That's kind of importing that behavior into the role. The inverse direction is even more interesting. Now I have a method called getPhone asked at the person object. If this person currently sits in his or her office, it would be pretty smart if he actually answers the office phone number, because otherwise the phone at home will ring and nobody answers. So if we're in the context, we want to be able to let the role intercept this method call and redirect it to the behavior in the role. And if you compare, I'm getting ahead of myself. The essence here is that conceptually we want to see the role and the base as one object. And these little wirings we are doing, forwarding this way, interception that way, are just wirings within the object, between the different slices, so to speak, of an object. This is conceptually is one object, just decomposed in its individual slices. And if we compare what we see on this slide with inheritance, then the call-out binding, the left-to-right binding is what establishes the acquisition of features that are inherited from the base. And the call-in binding is very, very similar to overriding the mechanism we use with a standard inheritance for adapting the behavior we found in the superclass. So very close, few differences, but I won't go into those details.
Can I ask a quick question as well about this? The method, kind of the mapping, right, that you have in this role, that kind of binds the role to a particular type of object. You know, it makes it less reusable, I guess. If you had, I don't know, another type of role that could be reused on different, or could be played by completely different types of objects, then the mapping. So I was just wondering, why would you not do no mapping at all and simply merge all the methods that are basically in the object as well as in all of the roles without any explicit.
Okay, so thanks for the question. So the question is, why do we do the explicit mapping and not do a merge? The reason is the merge would create implicit dependencies on what methods are in the base, and I want to make all this explicit. And as a good pattern for still decoupling even more would be to have an inheritance hierarchy of a super role which only has the implementation and a sub role which only has the bindings. So we can separate the behavior from the binding and use it just with inheritance that we can apply to roles. So wrapping up this part, which is the central contribution of object teams, whenever you find that inheritance is just too rigid and it doesn't deliver the flexibility you need for reuse, you have two options. Either throw tens, hundreds of design patterns at the problem, which bloats your application, or which means they're just workarounds in my understanding. Many of these design patterns are indications the language is not strong enough. Or you could use the instance-based composition supported by the language in object teams, where one instance can accumulate multiple behaviors and the instance can change its behavior over time, at runtime even. So this would be the item number 3 for you to take home, and this is how we do it. And maybe this should be the point where I should mention, although I'm explaining all this in terms of employee and person, all this is very, very much applicable to technical classes as well to classes from your business domains. Just one example, if you could say, I have an item in my merchandise management system and I have an order. Why not let the item play the role of an order position so it gets additional behavior in that context, etc., etc. Or we could say, if you need observer behavior, but a given class doesn't implement observable, why not just add an observable role to this class and add this behavior to this class, and maybe even dynamically at runtime? Don't think this is only for employees and students and persons. It can solve real hard technical problems. It can solve real problems from any business domains as well. So I have created a new kind of relationship between instances which could easily create a new level of spaghetti. If you like spaghetti, enjoy your meal. I'm in the software business, so I should better avoid spaghetti. And this question actually has two sides. We have to consider that the base objects and the role objects better be embedded in some modules that are larger than classes. One side. And now I'm getting closer to the initial question. Consider roles on the left side, base classes on the right side, and some bindings. Consider those base things reside in a module, and that module has an encapsulation boundary, and that's a pretty hard wall. Yeah, that means you cannot attach any roles to them, right? It means you cannot do any forwarding to these methods, which may be package visible, or you cannot even mention those names that you want to intercept. Yeah, that's what reality normally would tell you. So it only works for public things. Except there's a little conflict. Didn't I just say this base thing and the role slice are actually one object, then I just say this is one conceptual thing, and this would imply that I have an encapsulation boundary cutting right through an instance. That doesn't make any sense. I mean, that would be true split identity of this instance, and one side not being able to see the other side. So what we have in object teams is controversial, but we give it a name so we can actually discuss what we're doing. We have decapsulation as the inverse of encapsulation. And what we do is we allow you to explicitly specify the few locations in your program where you knowingly disregard the encapsulation boundary. And so now here's the little holes. These arrows are actually allowed to cross the encapsulation boundary, and it's like legalizing what has been prohibited before. And the advantage of this is that now those trespassers will be visible and controllable. If you don't do this, people will find their ways and you're not going to detect. If you make it visible, it's controllable, and you can approve or deny case by case if you want to allow this or not. And my experience is that by allowing decapsulation in a few locations, the total coupling of your system will significantly decrease, which is kind of a paradox, maybe, but it's my observation, and I invite you to play around and make the same observation. So, item number 4 for you to take home in our shopping cart is with decapsulation, we have this ability to actually bind a role to anything in the base application. It can be private, and it can be final. And we give warnings, and these warnings can be tuned to errors if the policy of a project says it's not allowed. But you have the technical ability, and now it's on the persons to negotiate what's allowed and what's not allowed. The other side of the role spaghetti concerns the roles, and here we actually have some more innovation waiting for you, because the roles are now embedded into a team instance, which has several advantages. The primary idea behind roles is actually that they are implemented as interaction between each other. So the functionality of this module, my team, is implemented entirely only in terms of those roles. And if role 1 would be tempted to invoke behavior of C2, no, it shouldn't. It should always talk to the role 2 as a representative. And so the only connections between the role level and the base level is through these declared bindings. And no direct method calls across this boundary. So this significantly increases the reusability of the team implementation, actually. And the comprehensibility maybe even more. This is number 1. Number 2, the team has one very simple capability. It has a switch, which you can turn on or off. Do you have an idea what the switch does? It has 2 consequences, one direct, one indirect. The direct consequence, if you turn it to off, watch this. The effect is that the call-in binding will fade away. If the team is deactivated, none of this interception magic happens anymore. So any changes the team imposes onto the system are disabled. And the cool thing is, this is not per call-in, it's not per role, it's per team. So it's modular. It's on a large scale that I can disable entire feature. I can put the entire application into a different mode. Create a new team instance, turn it on, I'm in still a different mode. Turn the team off again, I'm back into my previous mode. And so that's highly modular. And that's actually the last item we're going to put into the shopping cart here. The combination of role-playing and teams with a powerful concept of nesting and a powerful concept of inheritance creates teams as the ideal module to be reusable and to apply adaptations also to other modules in the system. So that's what we have. Team classes unify the concepts of classes and packages, so they're nestable, make nesting finally feasible. Team inheritance makes all the framework technology you know of more or less obsolete, because all adapting a framework can just be done by inheritance with deep overriding. With role-playing, we added a second relationship that's similar to inheritance, but more dynamic, more flexible. And with decapsulation, we entitled roles to specifically disregard some rules, if you wish to. And with teams as modules for roles, we made those adaptations themselves nicely understandable, comprehensible module again. So, being at a developer conference, I kind of feel obliged, before we leave the Zoom, to show you at least a tiny little bit of source code. So, if you download our tool, you can play around with this, and just by saying File, New Example, you will get offered a selection of prepackaged examples. And so the flight bonus example is the one thing I already installed here. And what is it about? It's about three things. First, I have a library, Booking Jar, which is a toy version of a flight booking system. So it has classes like, wait a minute, in the model package it has classes like a flight, a passenger, and a flight segment, and we could do some flight booking with these. The second part we have is something that would not be possible to implement without object teams. I entirely implemented but unbound module for any bonus program. So be it a frequent flyer, or be it a payback of your favorite video rental, anything where you can earn bonus credits while you buy some item. The abstraction of all these is implemented here, and almost all you see here is just plain Java code. The main difference is this keyword here. Wow. We have a modifier, this is a team. And then we have a subscriber, which has a field where bonus points are collected, credits are collected, and we have item role. This is the thing you're buying, and so this is responsible for calculating the credit. Left this abstract here, and then I have a method. So when this thing will be bought by the subscriber, we earn the credit by first calculating this and then pushing that value into subscriber collect credit. So it's implemented only in terms of what we have inside the Steam, but nothing magic happening here. And the hard question is, can we integrate these two modules, the bonus program and the flight booking? And neither one has any reference to the other one. Still, I want to create one application from both of them. So this is real reuse mashup. All we do is create a team class, actually fits on one slide, even at this font size. This is all we need to do. So we create connections in two directions. First of all, we connect to the implementation of the bonus program by inheritance. The entire collaboration with the inner classes and what have you is just extended by saying flight bonus extends bonus. This entitles us to create a class that overrides another class that is inherited. This is what it looks like. And inside that, we are able to refine the thing that were already defined in the super version of this same class. So, like, the super part is implicitly included here. And inside these classes, what do we have? We have a little implementation where the distance of a flight is mapped to a number of bonus points, and we are importing some of the methods using these call-out bindings. So we want to have access to the getName method of the passenger. We want to get access to the getStart, getDestination, and getDistance of the flight segment. And only two lines do the actual connection. Whenever the method book of the segment class, flight segment, is invoked, we want to combine this with our own behavior. Say, after that method has been invoked, additionally, please also invoke our earn credit method. Similar for the book method on the passenger class, but that's all there is. And although the flight booking was shipped as a jar, I only have to specify to the launcher that in addition to this jar, it should instantiate the flight bonus team and activate it. And now I have a flight booking application with frequent flyer logic in it. For reasons of time, I'm not showing this toy example because you can imagine that when I do some of this booking, at the console I will actually see you earned 2,000 credits. I hope you believe me. Otherwise, download the tool and play with the example. So this would be the slide version of the example. And if you like what you have in this shopping chart, to check out, you don't even have to pay. You just have to go to this website and check out eclipse.org/object-teams. Or if you already have a pretty recent version of Eclipse installed, just drill down in the like Indigo or Juno repository, just drill down to the program language category and find the Object-Teams development tooling and the Object-Teams Equinox integration, which would be another talk, extending this modularity even to the OSGI level. Great fun. So let me conclude by going back to where I started. OTJ is a seamless extension of Java to improve modularity for the sake of reuse, unanticipated reuse. And the Object-Teams development tooling, which you've seen briefly, is, well, I'm also a committer on this project. So I should be very careful with comparing quality of IDEs. Because nothing can compare. So this is a great IDE to base upon. By using our own technology to adapt the JDT, we're able, with much less manpower, to provide an IDE that has a very similar experience than the JDT has, but still knows about all the concepts of Object-Teams and provides the refactorings, provides quick assist and all this, what goes beyond the typical IDE, the basic IDE support. So, yeah, we are extending Java, we are adapting Eclipse. So I think this itself proves that we are able to do quite a bit of interesting reuse in unanticipated situations, and the result is extremely modular. So thanks for listening. I'm ready for your questions.
Another question. I'm just wondering, I'd never heard about this before. This was very interesting. Just wondering, who are your users? Is this an academic or is like it looks very interesting, but are there actually people using this for real?
Okay, so the question is, just briefly repeated about the user base. Is this just an academic project or is this for real? It started out as an academic project. We had a 3-year significant funding, which made the main contribution to the implementation and also made to make sure this is conceptually sound. But by moving this to Eclipse as a sustained project, the message is this is intended for a real-world application. So from what I know, so far still, the Object-Teams development tooling itself is the largest application of itself. I know there's a few users, but I mean, the opportunity here is to grow the user base. It will stay, I promise, and if you or your company is interested in that, you can contribute to ensuring that it will stay. But it is mature, it works in real work, and I'm in the midst of introducing it into my own company. I'm not owning it, but the company where I work at. But aside from that, I cannot show you examples of industrial usage, but I see no reason why this should not be possible. So many people like to be second. So maybe you want to be first. Please?
You added your keywords to Java language in files with the Java extension. You compile that on a build server with latent or something?
So the question was about adding syntax, adding keywords to files that have the .java extension. Can this be compiled on a build server? And in fact, this can be done pretty easily, simply because our compiler is an extended version of the Eclipse Java compiler. And the Eclipse Java compiler can be used in Ant builds, can be used in Maven builds. And if you do that, it can be used. Otherwise, the regular Java compiler will simply fail to compile this, certainly.
So you did not implement a cheat code in Java compiler?
So this picture is only part of the reality. The compiler itself is just too huge an adaptation because we first had to implement the compiler and then we already had the implementation. So this adaptation technology using object teams applies to anything in the UI. The compiler itself is a fork of the Eclipse Java development core. Yes, ma'am? Tooling support?
Like, for example, if you start programming and debug it.
So the question was about tooling support when we program with, can we do debugging easily? And yes, so this picture only says we adapted JDT. I should be more precise. We adapted JDT UI, which contains also refactoring and all that. We adapted JDT debug. We even adapted PDE, the plugin development environment, and its UI. So yes, there was a student who invested quite some ideas into improving the debug experience. We have an additional view where we can see the active teams, and we made some beautifying of the stack trace that you see, even some coloring and using JSR 055 to ensure that the debugger knows the correct source position, even if it's not plain Java code, and lots of these things. So if anything, and the experience with JDT doesn't directly work in the same way with the object teams development tooling, it's a bug, and you should file a bug in the Eclipse Bugzilla. The intention is that all this is supported. There may be little holes, but the intention, and we went quite far to actually achieving this goal. Debugging is definitely supported, and many of the other activities in the IDE are supported. Thanks for the question. So the question is if we're not getting into trouble with the key symbol, the arrow, dash greater. And my first attempts really were quite scary, but I pretty soon recognized that this is very local and very contextually. And so I only need to add a little bit of look ahead into the parsers so that in this one particular situation where we have an arrow, I actually didn't even show any location where it would be ambiguous. There is something like a parameter mapping where we can add details to a method mapping, where we can bind this parameter to that parameter, and then we have expressions and these arrows mixed. But it is possible to disambiguate this. It's work. It's pretty challenging work, but I have a branch already where the preliminary version of the Java 8 implementation, which I'm involved to anyway, so, is already merged with the Java, with the Object Teams Java implementation. So it will work. And it will actually create some very interesting scenario in the future. One more question?
Just wondering, I think there's a couple of really interesting ideas here. Especially, I think the teams and the roles are kind of orthogonal in a way. They're concepts that could exist without each other as well. I'm just curious, are you thinking about trying to influence the kind of the JSRs about taking some of these ideas in future versions of the language?
So the question was about teams and roles being kind of orthogonal, and whether one or the other, or eventually both, should be taken into the JCP and proposing this to be become part of the Java language. I made a little hint right when I explained team inheritance with virtual classes. This is probably the part that is most thoroughly researched in the OO community and the academic community, and it is certainly mature enough to push it into Java, certainly. But everybody I spoke to about this says it is just too huge a change for any committee to ever agree on this in a reasonable amount of time. And so I think it would make a perfect match in Java because it's so clear and fits so nicely into any object-oriented programming language. It deserves that space, its place there. Similar for roles, but I would if I would do it, I would do it in this order. First, go about virtual classes, and then about role-playing, and then combine both of them. I simply don't have the manpower to do this. If there is interest, each of these steps would be a great, wonderful gain for the Java programming language, and I would certainly support, but there would have to be some major player pushing this. Yep.
Yeah. So, of course, object teams can be used to develop new systems, right? But do you maybe have some experiences with converting an existing Java system to object teams? Or are there some guidelines, some refactoring that are commonly needed?
So the question is about given that the object teams is good for creating new systems, do we have experience and guidelines for converting an existing application into an object teams application? So the main experience we have is with adding object teams parts to an existing Java application, and that's really the killer application right now, and we can do wonderful things. We also have in this research project, we had a case study creating an entire application from scratch using object teams by just claiming the guideline: whenever you think of creating a package, create a team, which goes a long way. But we have no significant experience with actually converting an existing application into an object teams application. Might be worthwhile. Maybe this is something you wouldn't want to do in one step. My feeling, just from the top of my head, would be you would probably do it in small steps as you need it, as you need more flexibility in your program, as you need more encapsulation boundaries even. So object teams, despite having decapsulation, also has much stronger protection also of your objects. Whenever you feel you want to apply some of this to one of your modules, do it one module at a time, and I think you should be pretty fine. The cool thing is that by staying pretty close to the core of object-oriented programming, there's nothing fundamentally different. If you have a module, converting it into a team might be a no-brainer, actually. And for the places where it's not, the type system will tell you exactly where you need to be a little bit more explicit of what's happening. And it works best if you have a module where the roles where the classes that should become roles are never referenced from the outside. So the teams work best if a team is actually a facade for everything that's inside. Because then you can define a team just in terms only of classes that everybody can see, and gives you the means for very strong encapsulation. There's you can expose roles as well, but then you have to make sure to get the typing right, which, well, I mentioned there's some theory behind that. But as for refactorings or for guidelines how to do it, I wouldn't even think it would take very much to write those guidelines because of the close similarity to fundamental object-oriented concepts.
Just one more. For example, in aspect-oriented communities, they always have those examples that, we use aspects for logging, for security, for whatever. Is there some kind of some special types of interactions that you experience to be kind of the showcase for object teams?
So question is, when comparing to aspect-oriented programming, where they have the typical examples of logging and security, whichever, what you mentioned, is there some comparable interaction?
Some kind of example, like a model interaction that you would always say, this is the thing that you have to convert for sure.
So if there's a specific kind of module where we would typically always say this is where object teams should be applied, I mean, my personal experience is focused on developing tools, and whenever one of these tools doesn't exactly do what you want, this is a very strong indication to use object teams. But no, the general advice is whenever you have to do this, transform a near miss into a perfect match. It's always a strong smell that this can be very easily solved by using object teams. And this is one of the smells, and the other smell is if you have two modules, neither one knows anything about the other one. You want to combine them. How do you do that? Use a team that has roles into both of them and combines and mediates between the two behaviors. That's an even stronger indication that object teams would be what I consider the perfect solution, actually. And so I just recently did a little mashup using an Xtext editor, who knows Xtext, domain-specific language, and combine it with a Wikitext editor, and so they share one outline. It's impossible to do unless you use object teams. And it's a nice module, the combination. One more question?
Yeah, I was just wondering, combination of object teams with aspect-oriented programming, do you already have experiments with that?
Did you say combination?
Yes, so suppose I make some modules with object teams, and still I can have cross-fitting concerns.
Yeah. So the question is. So the question is, do we have experience in combining aspect-oriented programming like Aspect-J with the object teams approach? We had a few users who actually tried exactly this. I'm currently still discussing with the Aspect-J guys at the IDE level. There is some interaction actually between the two IDEs. It may work, but each team has each project has a few assumptions that are pretty difficult to reconcile with the respective other teams. So object teams has some similarity to aspect-oriented programming in the first place, except that it doesn't have the one thing that causes the maintenance pain if you use too sophisticated point cuts. We don't have this deliberately. So if you actually need that, we should probably work together, and it should work, but it hasn't been, we don't have much experience with that. Otherwise, if you don't need this really wide scattering, I actually recommend try using object teams also for those cross-cutting concerns. You may have to enumerate a few of those join points instead of just using a wildcard, but this may actually be an advantage. And so we have the same capability except for these wildcard things and point cuts. So either way, if it's feasible to do the same cross-cutting concerns also in object teams, this would be the easy solution. If you want to combine both, it should work. And I have successful experiments with having both technologies in the same VM at the same time, just not a whole bunch of real projects where I can say, yes, it's rock solid. We're not there yet, but this is demand-driven. So far, the demand wasn't very big, and if people are interested, it can certainly be reconciled. And I know the people from the AspectJ team are pretty good. And so if there's something they can help make it work together, we just talk it over a beer. So thank you very much for your sustained interest.